All right, this video is going to go over 5.3a, solving systems that have 3 variables. So that just means you're going to have 3 letters this time instead of just 2. Like you're probably used to just doing it with x and y's. You can have 3 letters though. So this first one's kind of misleading. You'll very rarely see it like this, where they give you one of them. If this happens, you're just going to plug it in. You're just going to do substitution. So it's going to look like this. Plug in 3 for z and solve that. And then you'll generally have another letter, like y equals -1. And then you would plug in both y and z into the other equation. So it'd look like this. -1 where y goes, 3 where z goes, and then just go solve it. So now that I have x, y, and z, my answer goes as a coordinate, x, comma, y, comma, z, like this. So this answer here would be 2, comma, -1, comma, 3. Like that. But again, that is extremely rare. What's generally going to happen is like this problem right here, where they don't give you anything. They just give you 3 equations. You're going to have to do elimination, and you're going to have to do elimination by eliminate same letter twice. So pick a letter, X, Y, or Z. It doesn't matter, but whichever one you pick, you're going to have to eliminate it twice. So I'm going to label these equations, equation 1, equation 2, and equation 3. If I add equation 1 plus equation 2, I can eliminate y, like this. So if I add these together, I would get 3x, the y's cancel, plus z equals -3. Cool. Now I need to pick a combo of 2 equations that when I add them together, eliminate y again. So now I'm going to do equation 1 plus equation 3. When you do this, you're going to have to scale this first equation. It needs to say -2y there. That way it'll cancel with the +2y below it. So I'm actually going to do 2 times this equation 1 plus equation 3. So I'm going to distribute a 2 here to this top equation. So it's going to look like this. 2x minus 2y plus 4z equals -3. Sorry, equals -6. And then I'm adding equation 3, which is this guy. So -x plus 2y minus 3z equals 7. Add them together. You'll get x, these cancel, plus z equals 1. Now, what you do is you take both of these results. So this equation and this equation, and you have to do elimination here as well. So like I'm going to make this say minus z. That way I can eliminate the z's. Blue did not change. Now, when you add these together, now you can eliminate the second letter and get -2x equals 4, divide and get x equals -2. Now, when you go find y and z, you can use any of these equations. So like, I'm just going to use this equation. Now I know what z is, 3. And now to get the last letter, you're going to use any of these equations, your original. So like, I'll just use that first one. I'm going to plug in what I know. I know x is -2. I don't know y. I know z is 3. Work it out a little bit. And now I know what y is. So your answer is a coordinate again. It goes x, comma, y, comma, z. Like that. Let's look at another one of those. I know that was a lot. So again, you're going to want to pick a letter to eliminate twice. So just looking at this, I'm going to go with the letter y again. So the first time when I eliminate it, here's equation 1, here's 2, here's 3. Just doing equation 1 plus equation 2 will work to eliminate that y. It would look like this. 3x, these cancel, plus 4z equals 15. All right, now I've got to eliminate it again. So when I do this one, I'm looking at this right here, and I'm thinking to myself, if this said -2y, when I added them together, it would cancel. So I need to do equation 2 times 2, then add it to equation 3. So I'm going to scale this middle equation by 2. So it's going to look like this. 4x minus 2y plus 6z equals 18. And then I'm going to add that to equation 3, which is minus x plus 2y plus 2z equals 9. I'm going to get 3x plus 8z equals 27. Now that I've eliminated the letter y, I'm going to take both of these results and try to eliminate another letter. All right, so I'm here. I'm trying to eliminate a letter. I'm looking at this 3x, thinking it's close. If this just said minus 3x, it would work. So I'm going to scale this top equation by -1. So that's what the top becomes. And the bottom did not change. Now when I add these together, I can get 4z equals 12. Divide by 4, z is 3. Once I know z is 3, I'm going to use either any of these equations really, but red or blue most likely. I'm just going to plug it in here. So it's going to look like this. 3x plus 8 times z is 3. So 3x plus 24 equals 27. Subtract 24. 3x equals 3. Divide by 3. X is 1. And then now you just use any of these original equations. I would use the very top one. I would use this equation. So it's like x plus y plus z is 6. I know x is 1. I don't know what y is. I know z is 3. Subtract 4, y is 2. So my answer is an XYZ coordinate 1, 2, 3, just like that. So the key is red and blue. You need to eliminate the same letter twice. I eliminated Y twice, here and here. Once you've eliminated it twice, you're going to have two equations that are your results, red and blue here. You need to add them to each other and eliminate another letter. I went with X, that's the green part. Then once you have one letter, like Z equals 3 or something, plug it into another equation, get your other letter, like X equals 1, then plug both of those into one of your original equations, get your third answer, write your answer as an XYZ coordinate. So that's how you do systems when they have 3 variables. They can get kind of tricky, so good luck. Hope this video helped.